Welcome, geometry students, to class today on this Monday, the 24th. Hope you guys are doing well. Hope you're ready to learn some math today. Go ahead and get out your books and notebooks and pencils. Also, let me make some announcements first, and we'll talk about what else we're going to do. There will be a quiz on Friday, so make sure you're ready for that. Please make sure you're ready for that. Some of your averages are a little low, so please make sure you're ready for the quiz on Friday. I will go over a little more in detail Thursday as to what will be on that quiz. You guys have nothing to turn in. The reason for that is you took a test on Friday. Okay, so there's nothing to turn in. Jace, I emailed you over the weekend. Hopefully you got that. A couple more homework assignments and then a makeup test. So just be in communication with me on that, and let me know what's going on. No rush on that. Make sure you're ready for the test before you take it, but do give me at least 24 hours notice, because I do have to make sure I have a test there for you to take. Okay, all right, and that's basically it. Now, I was going to go over your test. As you can see here, I had these slides typed up ahead of time. However, you should pause the video. If you don't have your tests in front of you, go ahead and pause the video and get your tests at this time. You should have them. But instead of me going over the test right now, if you look down here in the corner, I had little squares down here I was going to pull up, and then go ahead and go over your test with you at this time. But I'm not going to be able to do that because I've not graded all the tests yet up to this point. So here's what we're going to do. I am going to make a video. In fact, right now it's made. So I'm making this video right now, Saturday night. And so the video is going to be called, it's already posted, it's called Geometry Chapter 8 Corrections. No, I don't like that. Let's call it something else. We're going to call it Geometry Chapter 8 Test Corrections. So there's the name of the video, and if you'll look that up, you'll be able to find the mistakes. But again, the reason I could not do that right now is I don't want to go over every single problem in the test. That's pretty boring for you guys. What I did want to do is go over the ones that you missed, and I've graded them all except Haley's because I've not got her test yet out of my box. I will get hers out tomorrow on Sunday and grade it. And so if you want to find your mistakes on your test, watch this video later on. If you don't want to, that's fine. That's up to you. There is no requirement on doing that. That's totally up to you. Okay? I hope that makes sense. If you have any questions, call me or email me. Let's go ahead and get started now with the notes today. We are going to start Chapter 9 today. Chapter 9 is all about solid figures, okay? The last chapter was all about flat shapes, like a flat rectangle, a flat triangle, a flat parallelogram, etc. This chapter is going to be about solid figures. In this chapter, we are going to take these solid figures, and please look at what we're going to do. We're going to learn how to find their volume, and we're going to learn how to find their surface area. Volume and surface area. Just like Chapter 8, I will not make you memorize the formulas. However, you will need to be familiar with them. So you will not be allowed to put down the formula to finding the surface area of a cylinder is something. You'll just put down surface area equals, and you'll have to be able to match up that formula with the correct figure. Does that make sense? Just like your test on Friday, you had the formulas, but you had to know what each one went to or went with. Okay, so we will use that same method for Chapter 9. Now, unlike Chapter 8, there will be some fill in the blanks on your test. So do understand that, and you will have some of those on your Chapter 9 test. Okay? So with that in mind, let's go ahead and get started. Your heading today is solid figures. And again, my voice is still a little raspy, so just understand that, and we'll do the best we can. The heading is solid figures. The lesson number is 9.1, and the date today is the 24th, 2/24/14. Okay? Solid figures, lesson 9.1 to 24/14. Write this down. You'll need to know this. I will quiz you and test you on this. A solid is a three-dimensional figure. Now remember, I don't wait for you to write this down. I go fast. It's your job to pause the video and then move on. So please write that down. A solid is a three-dimensional figure. Let me get a drink here real quick. and we'll continue on. If you're a good artist, you can go ahead and try to sketch these in your notes. If you don't want to, that's fine. That's up to you. But do you get the idea of what I'm talking about? This is a solid. It has space inside. It could hold a liquid or something inside of it. This is like a box, so we call that a solid. This is a pyramid. This is the top of it right here, in case you can't see that. And here's the left side. The left side is a triangle. And then here's the right side over here. It's a triangle. Right over here is the right side. It looks like the bottom, the base of it, is a square, it looks like. Okay? And so we're going to be dealing with these different solids, and more than just these two in this chapter. But a solid is a three-dimensional figure, period. So any three-dimensional figure is a solid. Got it? Pretty simple. But now we're going to talk about a certain specific solid, and it's called a polyhedron. Please write that down. You'll need to know this. A polyhedron is a solid that is formed by polygons. Let me say that again. A polyhedron is a solid, so it has to be a three-dimensional object, a solid, and it has to be formed by polygons. Okay, let me grab a drink here. And it has to be formed by polygons. Now let me show you what I mean and see if this makes sense. Please take some really good notes, pause the video, back it up, whatever you need to do to make sure you get this. Watch. This would be a polyhedron. Let me explain why. Do you see how all of the shapes of the sides are polygons? See that? That's a rectangle. That's a polygon. That's a rectangle. That's a polygon. The bottom is a rectangle. That's a polygon. All of the sides, or the faces is a better name, all of the faces on this solid are polygons. And you might be thinking, well, Mr. Earhart, every solid is made up of polygons. Not true. That's not true. Look at this solid here. Notice this solid has circular tops. And remember, a polygon does not have curved edges or curved sides. Remember, a polygon is a figure made up of segments. We talked about this in the last chapter. It's made up of segments like that, and there are convex polygons like this one, and there are concave polygons like this one where there's a little indentation. Okay, but no, that there are not. Every single solid is not necessarily formed by polygons. Right here is an example. Look, the top of this cylinder is a circle, and a circle is not a polygon. A polygon is made up of segments. So this is a solid right here. This is a solid, and this is a solid, but only one of these is a polyhedron. This one is a polyhedron. This one is not. Okay, so make sure you understand that. Let's take a look at a couple more examples. Okay, how about this solid here? Is this solid here a polyhedron? Well, if you look at all of the faces, every single one is a polygon. You can even name them. This face here is a triangle. The bottom face is a square or a rectangle. I'm not sure which. The right side over here is a triangle. The left side over here is a triangle. The back side, I'll highlight it for you, is a triangle. So every single face, every single side of this solid is a polygon. And so this would be a polyhedron because every single face, every single side is a polygon. Now let's take a look at this example here. This would not be a polyhedron. It's a solid. This is an upside down cone. If you were to flip this thing up, well, I can't do that because they're all together, it looks like. There we go. If I were to flip this thing around, it would just be like a cone upside down. There we go. That's a solid. You could pour something in that. Okay, so this is a solid, but it's not a polyhedron because of this face right here. Look at that. That's not a polygon. The only time you have a polyhedron is when the solid is made up of all polygons, okay? And a curved shape like this is not a polygon. Let me get a drink here real quick. So I hope that's making sense. All of these are solids. Only these two are polyhedron. The plural form of polyhedron, by the way, is polyhedra. It sounds two. So we have one polyhedron. We have two polyhedra. Okay? That's how you say that. All right, moving on. Now please write this down. What is a prism? A prism is a polyhedron with two congruent and parallel faces. Now I'm going to give you some really good examples of this, so rest assured I'll explain this better, but go ahead and copy this down. A prism is a polyhedron with two congruent and parallel faces. Now, having said that, hopefully you see what we're doing here. We started off with a very broad term, a solid, okay? And then underneath that we have polyhedrons or polyhedra or a polyhedron, and then we have a type of polyhedron is a prism. So in other words, all of the 3D figures are solids, and then some of the solids are polyhedra, and then some of the polyhedra are prisms, okay? If you have a prism, then you definitely have a polyhedron, so you have a solid. A prism is a polyhedron with two congruent and parallel faces. Now, look at this. Please look at this. Do you see how we have this top side right here? We'll call it a face, and this bottom face right here. Now we're assuming we have right angles here and right angles here and right angles here and here and all over the place, okay? And if we have those right angles like this, and we're assuming that we do, then we know this top face, just like a box. Think of a box, okay? This top face right here that I'm shading in is definitely congruent. It's definitely identical to this bottom face down here, is it not? Sure it is. And aren't they parallel? I mean, this top face right here is running parallel to this bottom face down here. They'll never intersect, okay? And so we have a prism right here. This is a prism, and we know that because we have two congruent and parallel faces. And by the way, they don't have to be top and bottom. They can be side by side, left and right. You just have to have two congruent parallel faces. Now, having said that, by the way, because the bottom is a rectangle, and I should have mentioned this, this is called a rectangular prism. Write that down, please. This is called a rectangular prism because the faces that are congruent and parallel are what? What are they? They're rectangles. So we call this a rectangular prism. All right? Okay, let's continue on. Okay, now how about this? Would this be a prism? Well, students, you might say, well, Mr. Earhart, this left side right here is congruent to this right side. And you know what? Maybe you're right. I wouldn't argue with you. But they're not parallel. They're touching right here. Remember, you have to have two congruent faces that are also parallel. And you're not going to find that anywhere in this figure. Think about it. I mean, all of the sides, all of the four faces, the left, the right, the front, and the back, all of them touch up here. So none of them are parallel. And then the bottom face, this square right here, there's not a try to draw this for you here. There's not a square top, I'm not doing a very good job, but there's not a square top that's parallel to the bottom face. You have nowhere two congruent faces that are also parallel, nowhere. So this would not be a prism, okay? This would not be a prism. This is a pyramid. We can call it a pyramid, okay? But it is not a prism. It's a solid. It's a 3D figure. It's a polyhedra. It's a polyhedron, definitely, because all of its faces are made up of polygons, but it's not a prism. A prism has two congruent and parallel faces. All right, let me get a drink here and we'll continue on. Okay, if you want to write this might save you trying to draw these pictures in your books right here. But if you want to turn your book to page 100 or to page 473, example 1A, you might be able to write this in your book right here and not have to worry about drawing the picture, okay? But that's up to you. All right. Now, first of all, I don't have my book open. We're just going to answer a bunch of questions about it. First of all, I'm assuming they might ask you, is it a solid? It's definitely a solid. We can see it's a 3D. It's a 3D figure. Secondly, we can see that it's a polyhedron. We know that for sure, because every single face is made up of polygons. Every single face. There's no curved edges. The top is a triangle, the bottom's a triangle, the front's a rectangle, the left side's a rectangle, the right side's a rectangle. This thing is made up of all polygons. Now, is it a prism though? Well, let's see. We have to have two faces that are parallel and congruent. Well, here they are right here. See, this top side is a triangle. And see, this bottom side here is a triangle. Notice how they put those congruent symbols. 1 slash here, 1 slash here. 2 marks here, 2 marks here. 3 here, 3 here. This top triangle is congruent to this bottom triangle. And they're also what else? They're parallel. They're running the exact same direction. The top side or the top face will never intersect the bottom face. So, yes, it is a solid, it is a polyhedron, and it is a prism. And we call this a triangular prism. Okay, if you need to know that. I could very easily ask you to label these on a test or a quiz. It's called a triangular prism. Why, Mr. Earhart? Because look at the two faces that are congruent and parallel. Look at them. What are they? Are they squares? No. Are they circles? No. Are they rectangles? No. They're triangles. The two faces that are congruent and parallel are triangles. So we call this a triangular prism. A triangular prism. Okay, let's go on to another problem. Make note in your books. We're on page 473, example 1B. Now, by writing this in your notes right here, it'll save you drawing the picture unless you want to draw the picture. Okay, is this a solid? Definitely check. It's a solid. Is it a prism? No, it is not a prism. Excuse me, I got ahead of myself and I apologize. Is it a polyhedra or a polyhedron? No, it is not. No, it is not. Okay? Because of these curved edges right here. We have a circle. Remember, a polyhedron is a solid that is formed by all polygons, and this top face is a circle. It's not a polygon, so no, we do not have a polyhedron. Now let's go back and look at the definition of a prism. A prism is a what? A polyhedron. So if you don't have a polyhedron, you definitely can't have a prism. So we do not call this a prism. We call it a cylinder. Okay, it's called a cylinder, but it is not a prism, because you cannot have a prism unless you have a polyhedron, and it is not a polyhedron. Again, if I'm saying anything too fast, or if you're processing this slowly, then pause the video, back it up, and watch it again, okay? Watch different pieces again as you need to. All right, let's continue on. Okay, is this a polyhedron? Well, The answer would be yes. It's a solid, and notice how all of the faces are polygons. So yes, you can just kind of sit back and listen to this, or you can take notes if you want to and try to draw these figures in your notes. That's totally up to you. I'm just trying to give you a little bit more practice. Is this a polyhedron? Yes, because it's a solid in which all of the faces are polygons. I'll even take it a step further. It's also a prism, because this top side right here is parallel, and it's also congruent to this bottom side or face down here. And they're rectangles. So to be really specific, we would call this a rectangular prism. A rectangular prism. All right, now let's take a look at this one here. Okay. Is this a solid? Yes, it is. And again, you can just kind of listen and watch. Yeah, it's a solid, definitely. Is it a polyhedron? Definitely. All of the faces are polygons. You say, well, Mr. Hart, there's curved sides. There's no curved sides. They come to a point. It's still segments. Every edge of this face is a segment. Every single one. Okay, so this is definitely a polyhedron. Is it a rectangle? Is it a prism? Definitely it's a prism. This top side right here, we're going to assume, is congruent to this bottom face down here. And they're also parallel. So yes, it's a prism. It's a polyhedron. Check, check. And it's a prism. Now, what type of prism? Well, now watch this carefully. This is a six-sided face. 1, 2, 3, 4, 5, 6. So you look at the faces that are parallel and congruent, and that's this top and bottom face. And notice they have 6 sides, and that's called hexagon. So this is a hexagonal prism. Kind of a funny word, but it's called a hexagonal prism. Again, because what names the prism are the faces that are parallel and congruent. And the two faces that are parallel and congruent are hexagons. They're 6-sided polygons. So we call this a hexagonal prism. Okay, really makes sense to me. All right, now, if you want to make note, let me grab a drink here. If you want to make note in your notes, it might save you copying this figure down right here. We're going to be on page 474 at the top. I could have given you word definitions, and I chose not to. So I'm trying to be a little lenient here, but you need to know these terms. I could very easily on a test or a quiz give you an object like this and ask you to label these, okay? Now please watch. These polygons that are squares and trapezoids and rectangles, those are called faces. That's the top face. This is a face right here. This is a trapezoid. It's a face. Some students like to call them sides of the solid, and that's okay, but technically they're called faces. Alright? This would be a face over here. Looks like a square face to me. Alright? Or a rectangle. Alright. These little lines right here where the faces intersect, these are called edges. That's an edge. This is an edge. This dotted line back here is an edge. This is an edge right here. This is an edge going down. This is an edge going across. This is an edge right here. This is an edge right here. Hopefully you're getting the idea. The edges are the segments where the polygons intersect, okay? You need to know that. Now, the vertex. The vertex is where edges intersect. So see this edge right here, and see this edge right here, and see this edge right here. They all intersect right there. We call that a vertex. See this edge right here, and this edge right here, and this edge right here. They hit or intersect right here. We call that point a vertex. You need to be able to use those three terms intelligently and know what they're referring to as we get into harder and harder problems and start looking at formulas and stuff like that. You need to know what a face is, what a vertex is, and what an edge is, okay? All right, continuing on. Now in your books, if you want to go ahead and turn to this page, it's a really helpful page. It kind of breaks down the different types of solids, okay? For example, we didn't go into this in great detail down here, but we talked about prisms today. Here's a rectangular prism because the two faces that are parallel and congruent are rectangles. Here is a triangular prism because the two faces that are parallel and congruent are triangles. So we call it a triangular prism. Here's a cube or a square prism. We call it that because this face here and this face here are squares and they're parallel. Okay? And so it's called a cube or a square prism. All of these are pyramids. Notice how they come to a point. Okay? Why is this called a rectangular prism? Because look at the base. The base is a rectangle. Do you see that? Do you see that? Look, this is called a triangular pyramid. Do you know why? Well, look at the base. The base is a triangle, is it not? This is called a pentagonal pyramid. Well, isn't it obvious why? Look at your base. It's five-sided. And a five-sided polygon is called a pentagon. So this is a pentagonal pyramid. Okay? So it's named after the base and the fact that it comes to a point, so we call it a pyramid. Now, take a look at the cylinders, or what a cylinder is. Some solids are prisms, and there are different types. Some solids are pyramids, and there are different types. Some solids are cylinders, like this. And a cylinder, by the way, can be laying on its side. That doesn't matter. Okay? Doesn't matter. This is a cone. Now you say, Mr. Earhart, it comes to a point. I would think that's more of a pyramid. Well, now again, look at these bases. All of these bases up here in your pyramids were polygons. All of your bases were polygons. But this base here is a circle. That is not a polygon. And that's the difference between a cone and a pyramid. Yes, it's true that a cone and a pyramid, they both come to points at the top. That's true. But the base is what differentiates between a pyramid and a cone. A cone has a circular base, thus this base is not a polygon. And then obviously this last solid here looks like a basketball or a soccer ball or a baseball or whatever. We call that a sphere. Okay? This is a sphere, and it is very obvious. It's a circle. The way we show it on paper is a circle like this, then we show one going out flat like this to show it has depth, and it's just like a ball. Okay, a sphere is a ball, and those are the solids we're going to be looking at throughout this chapter, and you should be pretty excited about it. You're going to learn how to find. I mean, we've never found the surface area of an object like this before. We're going to be finding the surface area of objects like this, the volume of this, the volume of cones, the surface area of cones, all of these objects. Okay, and so it's going to be really, really cool. You guys will enjoy it, and it's going to be a really good challenge for you. Here's your homework. Let me get a drink here real quick while you copy this down. Now there is a homework help video like always, and I'm just going to scribble it up here. It's Geometry 9.1 homework, but here's the catch. Here's the catch. It's from last year. So this video right now that I'm circling is from last year. And so ignore everything that I say on there, please. Ignore everything I say on there except how to work the problems out. Okay? Just listen how to work the problems out. I'm going to tell you something else. If I were you, I would not turn that video on. Personally, I would do the problems, check them in the back of the book, mark the ones you got wrong, and then watch the video to help you. What about the even ones? Well, I would do the even ones, and I would kind of fast forward the video to the answers, and I would check the answers. Then every single one that you missed, I would watch the video for those. But that's your decision. If you want to watch the video all the way through and have it help you with your homework, that's fine. This is due tomorrow, page 477, 17 through 38 all. Please have it done. Have a great day. Call me or email me if there's any questions. And don't forget, there is a video you can watch if you want to find your test mistakes. And it's called, what did I say it was going to be called? It's up here on the first page somewhere. It's going to be called Geometry Chapter 8 Test Corrections. Geometry Chapter 8 Test Corrections. Okay? Hope you guys have a good day. Call or email if you have any questions.